and active sun. It's what we've currently got. Welcome, viewers, to the Daily Space Weather. We've got about 5 named sunspot groups, and a lot more than that to cover on today's Daily Space Weather video here from the Smash News Network, least busted name in news. Let's get to it. Here's some original music to go with it. Next, the colorized magnetogram. That was 94 angstroms from the Solar Dynamics Observatory. This is polarized light forming the colorized magnetogram. Again, we've got about 5 named sunspot groups. Significant activity here. Solar maximum-ish activity if we're talking about solar cycle 24 maximum. Anyway, that's the colorized magnetogram. Again, 5 about named sunspot groups. We'll get all in depth into it momentarily. First, 171 angstroms. The close-up equatorial view, just spectacular on your large screen. Radio flux now down to 125 solar flux units. Here's the 1-year chart there to put that in context. The black line here is the radio flux. The upper chromosphere and lower corona, meaning this area right here, emits radio photons. And they're the most proportional data set to sunspot number. You can see how proportional that is to each spike in the raising of the sunspot number. Discovered in 1947 by Canadian radio operators. The 10.7 centimeter radio flux. Space weather enthusiast dashboard not forecasting anything, but we've moved into a period of geomagnetic unrest. Yeah, currently there's a coronal hole wind stream striking, causing a change in the magnetic fields and the electron flux and more. Before we get to that, we'll look at earthquakes. There's been a bit of an uptick here. Quite a few earthquakes around the Pacific Rim and north of New Zealand. Let's roll up the list here. There was one magnitude 6 plus quake at least. This 6.1 at Fiji was at over 630 kilometers estimated depth. That would be over a 7 magnitude quake if that was at the surface. Let's hope that's not a foreshock. It could cause tsunamis. A deep quake in Indonesia. What's this one? There's one in the northern Mediterranean there near Greece. Not the most common spot. Not far from Athens. And leave us a comment if you felt that quake. And we're just going to scroll up the list here. South Sandwich Island saw another 5.1. Oh, and indeed there was a 5.6 not far from that initial one we reported there. Another very deep quake at Fiji right before that. Another deep quake at Fiji. A deep quake near the... Really, it's out in the Pacific Ocean there, south of Japan. Near the Volcano Islands, the aptly named Volcano Islands. Anyway, if we miss anything, let us know in the comments. Additional seismic activity there in Kansas, as well as off the coast of Oregon and off the coast of Petrolia, California. Remember, folks, any earthquake can be a foreshock. And let's look at volcanoes next. While we're doing geophysics stuff, here is the volcanoes. VolcanoDiscovery.com's Volcanoes Today page. Ionosphere continues to produce seismic activity. So something going on underground under Ionosphere, located in Iceland. 3,000 earthquakes have been detected since the solstice. Subinosejima also erupting. 4,000-foot plume of volcanic ash from Subinosejima. And Mount Yasur now back on the list. That's located on Vanuatu. Tana Island, part of the nation of Vanuatu. A low-level eruption there at Yasur. Hungatonga Hunga Ha'apai. 10,000-foot ash plume, flight level 100 as Hungatonga Hunga Ha'apai explodes. Fuego, located in Guatemala, also exploding. 16,000-foot ash plume from Fuego. 20,000-foot ash plume from Nevado del Ruiz. That's located in Colombia as Nevado del Ruiz explodes. Sangay in Ecuador, as well as Revenador, both of them erupting. Sangay producing a 21,000-foot plume of volcanic ash. Revenador producing a 15,000-foot volcanic ash plume. Sabancaya exploding, producing a 24,000-foot ash plume over Peru. That's a flight level 240. And I would remind our viewers to not pole vault the caldera. I would remind our viewers to visit smashomash.com/smashteam. And in our recent posts, we did put up some Christmas edits in 171 Angstroms, some custom edits there. If you'd like to spruce up your desktop, these are free, not just for paid silver, gold, and gold annual paid-up subscribers. We've put up a ton of free posts for the holidays and will continue through the old year, thanks to our paid members at the silver and gold levels. I would remind our viewers to forgive, remember, and hold accountable. Yes. Forgive and forget is so 2020. We need to forgive and remember instead. As many utterly incompetent people would prefer for you to forget so that they can avoid accountability for another year. So anyway, forgive, remember, and hold accountable. That's some positive feedback there. It's called wisdom. And you can find more of that at smashomash.com. Welcome to the Neo Renaissance. Don't forget to enter the promo code Santa Forgot. Don't you forget to enter the promo code Santa Forgot to save 20% on whatever Santa forgot to bring you. If he forgot to bring you a bike and you're now going to purchase one, or even an upgrade for your bike, hit me up. You can find links below the video to that, curated.com/e/dan.nigro, to get a hold of my expertise directly. And if you're a prepper and you don't have a bike, you're not prepped, welcome to the Neo Renaissance. Visit the homepage. You can find the links to the merch there, as well as to our forum. We've seen a divergence here in the GOES magnetometer. So let's get into magnetic data. So you see this divergence happening here as the coronal hole wind stream arrives. That gives us an indication as to where the initial strike of the coronal hole wind stream is happening. Keep in mind that GOES 16 and 17 are geosynchronous satellites. Their orbits are around 12,000 miles of altitude, well above the inner Van Allen belt. Anyway, that's 3 days, and we can see those readings starting to converge a little bit now on the GOES magnetometers. Next, the heliospheric current sheet. Earth is in a North Pole-oriented one, shown here in green. No changes expected to come anytime soon there. Most of our activity is in the southern hemisphere, but there are sunspots in the north as well. The likelihood of large flares is still quite high. Sunspot 2916 is facing right toward Earth. That's the line of sight ecliptic plane field plot. Here's a line of sight coronal hole plot, and you can see massive coronal hole area there in the North Pole orientation. This image also shows the solar B field in blue. Those potential field surface source lines, those are the sun's B field. We'll get to the Earth's B field momentarily. First, a visualization in 193 angstroms of coronal holes. I think those are all North Pole oriented. Indeed, those are all North Pole oriented coronal holes there, folks. And we're getting a wind stream from a coronal hole. At the moment, we'll get to it. First, sunspot analysis a little bit. Check out the size of sunspots in sunspot group 2916. It's got at least 2 sunspots that are larger than the Earth. This one up here is the second most likely to produce major flares. Let's take a little closer look here before we look at a more in-depth analysis and flare probabilities. Likelihood of major flares is very high, greater than 50%. Don't be surprised to see an M or an X-class flare come from 2916 or perhaps even 2918. Even this one down here, 2920, is a beta-class sunspot last I checked. And our coronal mass ejection warning is still there as well. We'll get to that as well. GOES X-ray flux underperforming. A large number of large sunspots on the Earth-facing disk, and only C-class intensifications for the past 3 days. No spikes on the proton flux. If we see an X-class or an M-class flare, don't be surprised to see polar radio blackouts and an ongoing proton flux signal. Next, the real-time solar wind to show a recent coronal hole wind stream strike. So you can see right here, right at about 8:42 universal time, we saw a significant uptick there in the solar wind density. Small uptick in the speed as well, and the density made it all the way up to 33 protons per cubic centimeter. There was also a significant negative BZ you can see in this top pane up here. The BTBZ was at 11 and negative 10. And that sparked the geomagnetic unrest. The geomagnetic unrest conditions are now going to subside as the BZ has moved back into positive territory. Current conditions are solar wind density a little bit elevated here at about 25 protons per cubic centimeter. Solar wind speed quite low here, under 400 kilometers per second, now at 389 kilometers per second. We actually did reach a KP4 here. This just hasn't updated yet. These are 3-hour bars, so expect to see geomagnetic unrest showing up there. We already sent alerts to smashomash.com/smash team. Thanks again to the Smash team. So here's the magnetohydrodynamic pressure over the past 4 hours. And you see elevated pressure here as a result of that high-speed coronal hole wind. Starting out as a high-density shock wave, being pushed by the rest of that coronal hole wind. That was Earth's geomagnetic moment from space. Here's Earth's geomagnetic moment from the ground. Ground magnetic perturbations, geospace delta B, changes to Earth's own B field. We're seeing some magnetic perturbations here in the equatorial regions, actually. And like the last frame, that's 4 hours of data. Let's continue on. Here's a diagram of the solar system. We're going to show you a 1-week forecast. And there's where things will be in a week. It looks like the new moon is coming on New Year's Day. A New Year's Day new moon. It'll be a great day for all you reverse werewolves. Here's a star chart. And the sun's about to pass the galactic plane, which is this blue line. The yellow line's the ecliptic. If you're up before dawn, you may see Mars rising ahead of the sun. What you won't see is Mercury and Venus rising behind the sun. The sun is too bright to see those. Next, the coronal mass ejection watch, rather. We're going to show you the view from Lagrange point 5 and Lagrange point 1, stereo A and the LASCO C3. So here's stereo A at Lagrange point 5 on your left, the LASCO C3 on your right, and you can see some ejecta here starting to make its way out as our yet another coronal mass ejection warning comes true. Expect to see continued activity here, especially if we see large flares. Today's cosmology segment is going to be brief. Check out our playlists for hundreds more at youtube.com/smashomash/playlists. First thing we're looking at is the launch vehicle for the James Webb Space Telescope and Comet Leonard on the same image. That's from apod.nasa.gov. Yeah, it's the James Webb Space Telescope launch plume and Comet Leonard on the same image. Anyway, if you want to look that up yourself, head to apod.nasa.gov. That's all we've got for today's cosmology segment. Again, check our playlists. We do have more material to cover. We'll have to do that at a later time. And by the way, thanks everybody for realizing that the channel exists, as cosmology is getting more and more important, looking more and more like astrology, and frankly freaking us out here at the Smash News Network, least busted name in news. Let's get back to the daily space weather. Some minor charging hazards here over the Central Pacific at the moment. Here's the electron flux over the past year. Those relativistic electrons from the inner Van Allen belt. Here is the electron flux over the past 3 days, and you can see this divergence consistent with the divergence that we saw in the GOES magnetometers. Now converging a little bit, you can see the GOES 16 went into warning territory, but the GOES 17 dipped. And we can expect to see a reduction in the electron flux, and the electron flux warning is going to go away here when the high-speed portion of the coronal hole wind stream arrives. Here's a relativistic electron forecast model, and it does tend to agree here for the most part. Again, we can expect to see a reduction in the electron flux with the arrival of this current coronal hole wind stream. Next, we're going to show you the total electron content forecast, which is totally chaotic once again. Massive GPS errors expected over North America, Antarctica, the Southern Ocean, the Southern Indian Ocean, and just generally large parts of the planet. Most GPS errors occur around the equator at noon, folks, and we've been seeing ongoing chaos for the past about 2 weeks. If you want to see what was going on with this on a previous day, go view our previous daily space weather videos. I think we've missed one day in the past 4 years. And we show the data daily so you don't have to go access it all yourself. It took us months to figure out even what data to show. Total electron content forecast translates to likely GPS errors. And we've corroborated this data with using GPSs. Next, the ionosphere, located at about 300 kilometers of altitude, is the F layer. Here's your ionogram courtesy Australian Government Bureau of Meteorology. Hopefully they're doing a little better job than our Australian Government Bureau of Virology. Anyway, that's the vibrational frequency at about 300 kilometers of altitude in the ionosphere, the F layer, the bridge between Earth and space, whatever you want to call it. Shout out to Tamitha Scove. Hit me up on Twitter. I haven't seen a response. We're looking to get Tamitha, I believe it's pronounced, Tamitha Scove on the channel. Correct me if I'm wrong. Here's the anomalygram showing anomaly in megahertz from the 30-day median. Tamitha did a great 4-hour video, a mini course about the inner workings and the physics of the ionosphere. It's a great video. Go check it out on her channel, Space Weather Woman Tamitha Scove. And here's the latest image. That's 1345 universal time on the ionogram. There's 13 universal time on the anomalygram. Bonus feature number 1 is the El Teide ground-based solar observatory. Let's see what's going on at El Teide, Spain, from the ground. We looked at a lot of instruments from space. Here comes one from the ground. Solar flare and coronal mass ejection watch. Warning, actually. Solar flare and coronal mass ejection warning. Continue. Here's the NASA GOES 16 SUVI. This one is great at showing coronal mass ejections. We may have to stream this one later today. Next, your latest intensitygram and colorized magnetogram. We show you the refresh so you know that they're the latest. That's a beta-class sunspot capable of producing large flares. That's just a massive sunspot. Beta-gamma class, certainly, capable of producing large flares. That's an alpha-class sunspot, unlikely to produce large flares. And in the northern hemisphere, that one is also capable of producing significant flares. Look at all the different polarity fields there. Well, we'll get to it in the magnetogram. That's capable of producing big flares, and even that one is capable of producing large flares. It is a beta-gamma class sunspot. Let's go backwards. There you can see all those fields of different polarities. That is what enables sunspots, or is correlated with sunspots, producing large flares. They need both polarity field umbrae. Anyway, continuing down, here's the rest of your colorized magnetogram view. 2916 is certainly noteworthy. You can even see the penumbra in the colorized magnetogram there. Some penumbra there as well. And we'll close out today's daily space weather video in 304 angstroms ionized helium. Check out the lines radiating out of this in helium. You can see absorption features there showing up as dark regions, as well as these light areas, which are areas of very high helium concentration, as nuclear fusion is happening right there on the surface of the sun in plain view. Anyway, thanks for tuning into the Daily Space Weather video. Don't forget to tell your friends and foes about us. The algorithms don't seem to be doing it. Congratulations on realizing that the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network. Least busted, name and news.